Hi everyone, I am Wilmer Contreras, electronic engineer and member of the automation group of the INM Colombia. This group automates the measurement processes of the laboratories. In this case, I am going to present the prototype of digital calibration certificate applied to the measurement service in time and frequency. Firstly, I want to share with you our experience within the digital framework of the international system of units of our first approach to the development of the digital calibration certificate. Our development was with time and frequency laboratory service. In this specific laboratory, there is an application for measuring the synchronization offset between external clients entity server and the INM entity server. Within the hierarchical structure of legal time, we have our national standard, a session atomic clock in stratum 0. Toward lower levels, we have two entity server in cascade. Our clients connect the entity server to the stratum 2 servers of INM to perform the synchronization of the server through the entity protocol. This application is installed directly on the client server or computer and capture the timestamp from MTP protocol every 16 seconds and store the data in a local database. This application was developed in Java language and generated in an automatic report in an Excel format every 24 hours, which is sent via email from the application to the time and frequency laboratory. It contains all data obtained from the measurements and statistical summary showing values such as maximum, minimum, mean, coverage factor, and expanded uncertainty. This XML file is the main input to create the digital calibration certificate. The file must be entered by the user into the application that issues the DCC. Okay, in order to issue the digital calibration certificate, we rely on the structure that the PTP proposed. PTP has a free wiki for consultation that contains the XML schema and it can be validated through the XSD file contained on the same web platform. There, we can find the detail of the different labels which contain all the information of a digital calibration certificate. Okay, now I am going to talk about the software development in order to issue the DCC and how we implemented the web application. We decided to work with DJANGO, that is an open source web platform written in Python with a model view controller design pattern. On the view side, we find the development of the user interface or frontend using languages such as HTML, CSS, and JavaScript. The controller or server was done using Python language, which is responsible for processing all requests on the input Excel files. Finally, the model or backend is a database written in SQLite. This software design pattern allows graph scalability for the application. This is a high-level architecture for the issue process of the digital calibration certificate. Firstly, the hierarchy of NTP server The premium legal sign application installed on the client's NTP server, which sent an automatic report every 24 hours by email. And finally, the platform developed which issues the DCC. In the platform, we upload the Excel file generated by the Nesurimen application, and the controller make the queries to the database, then process the file in Excel, and issue the DCC contained in a XML file. Mm, This DCC is generated according to the International System of Units and the specification of the ISO 70025 Guide of Uncertainty Measurements, Vocabulary International of Measurements, Code Data, and contains the administrative data, calibration results, comments, and PDF calibration certificate with a digital signature from the metrologist. Now I am going to present the web app user interface and the information on the XML file, which contains the digital calibration certificate. Um, This web platform is running on the virtual Linux server, and it has an interactive interface. The user can modify the different forms that contains the administrative information and the calibration results. He can select the Excel file that contains the measurement report generated by the Premium Legal Sign application. Also, the platform extracts the measurement data and hosting them directly on the generated XML file. Also has a preview option that shows how looks like the final results of the digital calibration certificate before generating it. Once all the files of the user interface are completed, the user can download the XML file that contains the DCC. Here, in the different labels, all the information of the calibration certificate is hosted. And finally, this XML file is validated against the XSD schema proposed by the PTB. This structure has labels with the connection links to the web page that contains the XSD of the PTB. In this case, this DCC is made according to the minimum mandatory parameters proposed by the PTB structure and is validated before generating the XML file. This is our first prototype. It is still in the testing phase with internal users. We have a long to improve this platform and implement it to the other service and laboratory of the INM of Colombia. Thank you very much for your attention.